video, we're going to explain the construction of phylogenetic tree. Phylogenetic tree, also known as molecular evolutionary tree, which is a method in bioinformatics to describe the evolutionary relationship between different organisms or genes. Systematic classification analysis can help people to understand the evolutionary history of all living organisms and living things. And there are many forms of evolutionary tree, as you can see here, and all the tree show the relationship between organisms or genes. And why build a phylogenetic tree? In order to solve the biological evolution problem. And phylogenetic is a powerful approach in finding evolution of current day species. And by studying phylogenetic trees, scientists gain a better understanding of how species have evolved while explaining the similarities and differences among the organisms. There are several methods and principles for constructing phylogenetic tree, such as distance-based algorithm method, which include unweighted peer group method with arithmetic mean, neighbor joining method, minimum evolution, and Fitch-Margolis method. And character-based tree searching method involve maximum parsimony, maximum likelihood, and Bayesian inference. And there are certain software which are used to construct phylogenetic tree. A list of software is given here, such as BioID, DNStar, MEFT, Muscle, ClustalX, Gblock, Philip, Mega, and ITIL, evolutionary tree display and editing tool. In 2017, a research paper published which used rhizosphere soil, root, stem, and leaf tissue as a sample for 16S amplicon analysis, and the purpose of the study was to analyze bacterial community structure in different ecological niches. And the author constructed a phylogenetic, circular phylogenetic tree, such as you can see here, which is used highly abundant bacteria related to different ecological niches, and then he used ITIL website for the beautification of phylogenetic tree. In this lesson, we're going to discuss and we're going to explain step by step how can we construct input file, how can we generate input file by using window local analysis, and then we can use ITIL website for the beautification of that tree step by step. Basically, phylogenetic tree construction process involves raw data edit, which can be performed by Mega7, BioEdit, DNStar, BLAST by NCBI, IMBL, and DDBJ, dataset conduction, result of BLAST and references, alignment with the help of Muscle, MEFT, and Mega software, and model test can be used by Model Finder and JModel test, and phylogenetic analysis using FastTree, RexML, and IQTree. And commonly used software for building maximum likelihood tree is RexML, Mega7, FastTree, IQTree. Although RexML is very good, but it's still not fast enough, and it has certain limitation because it needs to convert format and cannot select evolutionary model. Since IQTree introduced in 2015, it has been cited more than 20,000 times, and it surpassing RexML. And when you use IQTree website, you can see such kind of a page, and it has certain key features such as it can use for efficient tree construction, and you can use fast and accurate model selection, and it's super fast self-exhibition, and it can be used for support big data computing. And you need input file in the format of Philip, FASTA, Nexus, and Clastal, and it's the best model choice because Model Finder is a super fast automatic best model selection software, and IQTree integrates the Model Finder module to quickly obtain the best evolutionary model for the target data. Model Finder software was published in Nature in 2017, and it's about 100 times faster than the currently most popular JModel test. And you can see the citation is 6718 times in the research articles. Basically, we can use usearch for quickly extract the FASTA sequence because during sequencing comparison and microbial diversity analysis, it is often necessary to extract FASTA format sequence files with specific IDs based on specific information and relative abundance. The traditional method is to search, copy, and paste each ID, which is very slow, and the efficiency is low and prone to error. Alternatively, we can use usearch to extract sequences, such as using HR to perform differential analysis or high abundance bacteria in all sample, and we have the code in our pipeline for the extraction of sequencing, and we can process and filter OTU sequencing and annotation information based on abundance threshold or quantity. So for this, we can see later that in the pipeline, this usearch we used for evolutionary tree. And what we can do that we just like it's given here that just give the ID of the sequence, and then we can extract the OUTS file, FR file. And usearch, this command, this code is given in our pipeline, and we get OUTS.FR file. And then we use muscle software for sequence alignment, and by using this code which is already given in the pipeline, we just execute the code step by step. And then sequence alignment using online math is also this option is given. You just copy and paste all FASTA sequence into the text box. You can see here, and uppercase, lowercase, select same as input, and then you have to give your nucleotide sequence direction, and then ultimately we get output same as the input file, and then click submit and save the result in the email. You will get your OTUS aligned FAST file, and the link is given here for the MF comparison website. And the IQ tree usage step, you need to perform multiple steps. The first step is you have to prepare sequence, and for sequence format requirement you need Phylip and FASTA, and in the second step you have to prepare your program file. iqtree.x file is already located in our EasyAmplicon database directory under the window directory, and make sure the bin directory is in the environment variable. And then we can construct ML phylogenetic tree step by step, and then we can upload our file in the website, and then we just execute one by one our plan or schemes according to what you required, because we have to generate some input file for uploading in IQ tree website. And then this is the ITIL website. You can see here you have to upload your generated file, which we generate later in RStudio, and then we will upload here in ITIL website. And we have to prepare input file, annotation text, and OTU tab text here. And then we can modify our tree like this. We can annotate each OUT according to subject level, and then we compare chart for the beautification in different groups. We can add circular annotation in class and order level, and then we can use this thing. Now let's go to the RStudio and run the command for the evolutionary tree step by step. Now we are in the section of evolutionary tree, and we are in our working directory, the EasyAmplicon. Now we have to execute this code. Here we're gonna create directory under result with the name of tree. Let's run this code. Now see here. Now we just generated this directory tree. Now we're gonna filter high abundance specified feature. There are several methods to perform this. Method 1 is filter feature based on abundance. Typically selected this parameter with the OTU count falling with a range of 30 to 150. And then we count the number of ASVs in the feature table. We will execute this code to count the number of ASVs. Let's execute this code. Now it gives us the count of 1363. In order to filter the high abundance OTUs based on relative abundance threshold of 0.2%, and now we're going to use usearch OTU tab frame, and then we're going to use OTU tab rear text file, and then we get output OTU tab text. Let's run this code. We can open this. Now we see here we get OTU tab text file. Now, in order to count the number of features in the filter OTU table, we're going to execute this code. And now it gives us it gives us 85 features. There is available method 2. Method 2 is also available. You can see here filter based on quantity or count. You can use this one either. So in order to modify the column name of the feature ID, we will run this code. And we can extract IDs for sequence retrieval by using this code. You can see here we generated OTU tab high ID. Now, in order to filter high abundance bacteria and specify differential bacteria associated OTU sequence, we use this command which have usearch fastx get sequence, and now in the output is otus.far file. Now see, it generated otus.far file. Now filter OTUS based on species annotation. Now, in order to obtain group mean value corresponding to OTUs for use in generating a simple heat map, now we're gonna execute this code. The result will be OTU tab high mean. You can see here OTU tab high mean. Now we are going to merge species annotation and abundance into annotation file by executing this code. You can see here we get annotation.txt file. Now come to the step of build an evolutionary tree. The starting file are required here, otos.far file, which we have here, annotation text file we have here. So we use here muscle software for sequence alignment. Let's run this code. Now see, it start processing and it takes few minutes. And then we are going to perform to build IQ tree to quickly build ML evolutionary tree. We have several methods here. Method 1 is available here. Method 2 is also here under Linux environment. So we prefer method 1. Just run the code. Now it's processing. Start here. You can see it takes some minutes. Now see, it's running. Now it's get done. You can see here it gives us the date and time, and now we are again in our working directory EasyAmplicon result tree. Remember, in method 2 we use FASTA tree software, and input file is in the format of FASTA, not the usual FILIP format, and the output is NAVIC format. This method is suitable for big data such as phylogenetic tree of 100 of OTUs, and to install FAST tree on Ubuntu you can use apt install FAST tree and you can run this command. And we already created some file here, and now you can see we generated the directory of IQ tree here. And now the steps is for evolutionary tree beautification. In order to beautify, we just run the commands to have some schemes like scheme 1 here, scheme 2, scheme 3, scheme 4. In scheme 1 you can see we are going to give outer circle color, shape classification and abundance scheme. And in scheme 2 you can see generate abundance histogram annotation file, and in scheme 3 you can generate heat map annotation file, and in scheme 4 convert integer into factor to generate annotation file. And after generating all these schemes or plans, we will visit this website. Let's copy this link and come here and paste over here. Now you will see that it will open ITIL web page. Now we get this page, welcome to ITIL, and we can see here we have different feature, manage, annotate and export. Normally we will use annotate to upload a tree, and then we will beautify our phylogenetic tree. Let's see here in our directory. In our working directory, we will see the file we just generated by using the commands. We see here we're gonna upload first OTUS tree here, and after let's finish this step that we have to generate the schemes which we're gonna use here one by one. So let's run the code. Scheme 1, we're going to give outer circle color, shape, classification and abundance scheme. You can see here it's plan 1, which use OTU ID genus, and we can get annotation text here. So let's execute this code. And in scheme 2 we're going to generate abundance histogram annotation file. In scheme 3 we're going to generate heat map annotation file. And in scheme 4 we're going to generate which convert integer into factor to generate annotation files. Now you can see here plan 1, plan 2, plan 3, plan 4. Now come to our working directory and see here in plan 1 you have multiple files of class, text, kingdom, phylum, species, family, order, alt text and gradient. And then you have plan 2 similarly like this, and then plan 3 and plan 4 so far. So what we're gonna do, we come here, we click upload tree, and upload, you can give any name and you can just copy the text here. So first of all you have to create account here. Let's register. When you open this page, you have to create your account. You have to first register and then you will continue with this. So first, I already created account here, so I will just click the option of sign in. I will sign in. Now I can use my tree. And now I am going to upload my files one by one. There is option tree upload. I have to select our files. I will select first result under tree, I gonna first choose IQ tree and then I will choose OTUS country file, open it here. Now you can see here we have OTUS country here. After uploading OTUS country file, we will click here. Now we can see, and now you can, on your right hand side, you can see the control panel. Just go to the datasets. And now we're going to upload our annotation file. Now see, we have our plans 1, plan 2, plan 3, plan 4. For example, we choose plan 1 and then we're going to select all these files, open. Now you see this is now you see the different colors. Now you can use these commands to modify your tree. Like let's suppose we do zoom out to see. You can drag. Now we can see the advanced setting as well. In the advanced setting, you can see you can play with all these parameters one by one. This is, you can see in circular. You can see here I got here circular phylogenetic tree. You can drag it and you can choose many parameters which you want. For example, you can have our leaf sorting, you can choose the size and length, and you can get the legend of all what you want. You can, for example, you can, if you want class, you can remove data class from the data set if you want to do this. So you have many options. You can choose any one which you want, and you can get rectangular as well. You can get unrooted as well. You can see here. For example, we can zoom out and in order to see these options. Now see, this is unrooted phylogenetic tree. So you can adjust according to your research and according to your finding and what you want to show to the reviewer and to the readers. You can see this. Now, if you want to change your plan, you just come here in the dataset and you can see the views. You can come here. You can, if you want to save this, you can save this, and you can save this image in your working directory. Now come to the my trees. If you want to leave, I don't want to change, you may not be saved because I didn't save it, but make sure you have to save it first and then you will go to your plan 2. I come over here again, OTUS country. I'll come, open this page again, and then in the control panel, go to the datasets, upload annotation file, and now we will select plan 2 and select all these files. Now you can read this instruction that label changes are not automatically propagated to multi-style labels, and then you can choose basic. You can zoom out first and you see what the color schemes or under this plan 2. This is, you can see here, it's look beautiful. And now see, this is the, as you keep your precursor, you will get the information, and then you will go to the circular. You can see here, and if you want to choose rectangular, you can use rectangular as well, and this is unrooted. Zoom out and you can see this. If you want to move the legends, you can move it, and then if you want to save it, you can click this button and you can save this image before proceeding to the plan 3. So let's go to the plan 3. Click here again in the under OTUS country, and then go to the datasets and choose upload annotation file, and then we are going to choose plan 3. And here we have only one annotation file of heat map OTUID text. Let's open it, and now you get heat map. You can see here we have a heat map here of our ASVs. You can see, and then you can use circular heat map as well. You can use rectangular, which we already by default, and then if you want to do unrooted, you can select that one. You can see here. So you have many options to play with this. Now come again to the OTUS country, and then we will see the plan 4. Come to the dataset, upload annotation file, and select plan 4, and select all these annotation files. And now you can see here the color scheme. You can see here it's look good and it's beautiful. Although as we can get it circular, we can see here in the rectangular format, you already saw it, and then under unrooted you can see here. So all these modification you can do. You can further do advanced setting by changing this parameter, and then you finally click the export button. You can save it in your working directory, all these files one by one. So far we learned in this lesson that how can we generate phylogenetic tree, and how can we screen high abundance OTUS data, and how can we run the command in RStudio using local Windows system, and then how can we use ITIL software to draw and to beautify our phylogenetic tree. So this is all about phylogenetic tree. And come back to the RStudio and execute this code in order to come back to your working directory. And alternatively, you can generate evolutionary tree, and you can visualize the evolutionary tree by using ImageJP and further